let me tell you that many have done so. On an occasion like this, as I told Dr. Gopalan, I was debating in my mind what should I talk to you. And I decided that I am going to give you to the horizon of linkages of chemistry with chemical industry in its journey all along. Let me give you an outline of what is the size of chemical industry. Global size is $2.5 trillion. More than 100,000 chemicals are in the market. We go from nano size to mega size. We produce some chemicals which sell few lakhs per gram. We produce many chemicals in millions of tons per annum. Like ammonia is produced in China at 40 million tons per annum, plus in India 12 million tons per annum. We have plants where single location, single stream, maybe 5,000 tons per day, like methanol, and very soon ammonia would be at 3,000 tons per day, single stream plants. No part of industry has been so critical to quality of life as chemical industry. You look at any aspect of quality of life, from health, food security, and entertainment, and you will find that chemistry plays a pivotal role. If you look at entertainment, from the CD disc to fireworks, you will find display of chemistry in plenty. From the example of simple molecules which act as anesthetic agents, starting from ether to today fluorocompounds, which are extensively used as anesthetic agents. You can have oral anesthesia or local anesthesia. How they work wonders. Even in terms of fighting terror, how we have weapons of peace, which are all chemical, like from tear gas to whatnot. I'll take you back to 1850s, when first major development took place, when Perkin came out with Moab dye. That was the starting point of how original research gets converted into something of very great importance. I want you to know that all the renowned companies in the world, whether DuPont, ICI, Dow, all of them in the beginning had their origins in dyestuff chemistry as well as explosives. Now explosives have double role. They are essential for mining, but they can also be used for destructive purposes. And you hear about it every now and then. After that came a very major breakthrough in 1865, when a polluting process for making soda ash by Leblanc process, where you reduce sodium sulfate, you will learn in your school chemistry, Na2SO4 to go to Na2S, and you carbonate that, you get sodium carbonate. Unfortunately, it generates H2S. And you talk a lot about green chemistry today, but the birth of green chemistry goes back to 1865, because this plant was ordered closure in UK, saying that miles ahead of that plant you can smell rotten eggs. And solvate process was born. The beauty of the solvate process was two most inert molecules that you ever know, sodium chloride, which remains for millions of years in ocean, calcium carbonate, which remains in rocks for millions of years, that both were coaxed to make soda ash, Na2CO3. Now you write an overall equation, 2NaCl plus CaSO3, giving you sodium carbonate. It is deceptively simple. And how, before chemical engineering was known as a recognized discipline, chemical engineering was born with the solvate process. And the trick, what I am trying to tell you is that how you get inspiration. See, research is a passion. If you are not passionate about research, you don't go places. In the final year of your PhD, I hope you have now become somewhat passionately attached to research. And And the beauty of chemistry is a predominantly experimental science, and you don't know the results. And you often hear about accidental discoveries, serendipitous discoveries, and I'll give you some very renowned examples which were serendipitous. And the serendipity never struck uninitiated persons. They were always very talented persons who could catch this serendipity. So this Solvay process was the first example of a polluting process being replaced by a clean process. And the trick was ammonia brine solution, carbonate, make use of principles of physical chemistry, which on the whole in our country is somewhat weak, and the latest edition of Chemistry World shows you virtues of physical chemistry. Those who are doing PhD in physical chemistry, I want to encourage them, they have plenty of opportunity. I have had unique advantage of having dabbled in not only chemical engineering but various aspects of physical chemistry, inorganic chemistry, organic chemistry, so I can talk to you with some passion. Physical chemistry is extremely important, and how principles of physical chemistry were deployed, because one made use of the solubility product concept, because soda bicarb has very limited solubility. So when you carbonate ammoniated brine, soda bicarbonate precipitates out, you calcine that and you get sodium carbonate. And jump by a few years, and sulfuric acid was made by what we call chamber process, again which you learned in your school chemistry. And it got replaced by what is known as contact process. Now contact process was the first major example in the history of chemical industry where it was vapor phase catalytic process. The vanadium pentoxide catalyst is still order of the day, and the advantage is when SO2 reacts with oxygen, if it reacts it can only give you SO3 and nothing else. So the thermodynamics was very fascinating, and contact process sulfuric acid completely supplanted lead chamber process. I take a jump by many years to tell you the birth. I'll give you milestones so that you get an idea how high science, how unfettered research gets directed towards utilitarian part. Research is the beauty of its own. Many times you do research. For example, reference was made to Ernst for NMR. Now please bear in mind that when NMR or X-ray or anything that came in the beginning, or lasers, nobody knew how far this will be used. Today, MRI has become an integral part. Even the laity knows that there is a thing called MRI. Like earlier days, every person in the street knew that you could take an X-ray of the chest. The first petrochemical was born around 1920s, when heavier fractions which had very limited market were thermally cracked, and in this thermal cracking one got propene. The first petrochemical of the world was isopropanol, made from propene via absorption in sulfuric acid, dilution, stripping. This was a major milestone because the whole petrochemical industry, which today has a very heavy stake, dominates chemical industry, was born then. This was not a clean process, because you absorb with sulfuric acid, you get some base sulfuric acids get diluted, you have to reconcentrate. It's a little messy operation. Today, it is entirely catalytic process. The catalyst may be cationic ion exchange resin or heteropoly acid. I know there is interest in catalysis in Goa University. I am also going to give you from time to time examples of breakthroughs there which turned fundamentals of business. This catalytic process today dominates making isopropanol. Then it was taken to secondary butanol, which was also done by butene absorption in sulfuric acid dilution distillation. In fact, same thing was done to get pure isobutylene from the C4 fraction consisting of isobutylene, butene 1, butene 2, and butene 2 has two isomers, cis and trans. That also was done by absorption in 50% sulfuric acid dilution. Today, that is also completely catalytic, and the first major catalytic process based on cationic ion exchange resin practiced at millions of tons per